Number 17 asks for the domain of three functions. So to review domain, no division by zero, no square roots of negative numbers, no log of zero, because that's a question that can't be answered, and no log of negative numbers, because that gives us a complex number. The square root of a negative number gives us an imaginary number. We want real numbers into our functions, real numbers out. So here we have a square root function with a quadratic underneath, here a logarithmic with a linear inside it, and here we have a rational function with a cubic in the denominator. So we're going to do these one by one. So for this one, the first thing I'm going to do is factor out the negative sign, so I have a positive x squared. So that's x squared plus 4x minus 5. Then I'll further factor the trinomial. I'm going to have an x plus and an x minus because this is negative here. My middle term is positive, so I'm going to put a positive 5 here and a negative 1 here. So if I sketch what's inside here, if I do a negative, well, just looking at this, it's downward pointing. My y-intercept is 5, and then 1, 2, 3, 4, 5, 1. Then I'm going to have an x-intercept here and an x-intercept here. So my quadratic function is going to look like that. So we can take the square root of 0, so our domain is going to be -5 inclusive up to and including +1. So taking a look at the solution, so they pretty much did the same thing, -5 to 1 inclusive of the endpoints. So then going on to the next problem, I can't answer the question log base e of 0, and I don't want complex numbers coming out of our functions. So we're going to say 4t minus 3 has to be greater than 0, 4t has to be greater than 3, t has to be greater than 3/4. So in interval notation, 3/4 to positive infinity. We'll go check the answer on that. And 3/4 to positive infinity. And going on to the next one. So to factor this, I'm going to use factoring by grouping. So x squared in the first two terms. So I'm going to factor that out. So that's x plus 3. Then here I'm going to factor out a -1. So that leaves me with x plus 3. So that's going to further factor to x plus 3 times x squared minus 1, which will factor to x plus 3 times x plus 1 times x minus 1 by difference of two squares. So I can't let x equal -3, -1, or +1. So the domain is going to start at negative infinity, go up to but not including -3, union with -3 to -1, union with -1 to +1, union with 1 to positive infinity. And if I go check the answer, same for interval domain. And just to show you what you can do with the calculator, I've gone and put in all three functions. So this one turns out to be a semicircle. So there's the logarithmic, and you can put in vertical asymptotes if you want. So I'm going to go to menu, 3 for graph entry edit, 2 for relation. I'm going to put in x equals 3/4. So I get my vertical asymptote there. And you can even get a little bit fancier. So I'm going to go control menu then attributes, and I can make that a dotted line. Then moving on to the third function, I've already got the vertical asymptotes in. And now I'm going to go to a calculator page, go to the catalog, which looks like a big book, domain, put in my f1 of x, comma, x, and it tells me what the domain is in inequality notation, not interval notation. So domain, now my expression is going to be f2 of x, and x is my variable. So non-inclusive, 3/4 to positive infinity, and then another domain, now it's going to be f3 of x, comma, x is the variable. So again, it's inequality notation rather than interval, and you have the 3 breaks, which gives you 4 intervals. That concludes this video.